Okay, we're doing throw-up problems today about the height of an object over time. Here's the basic equation. What is the anybody remember what I said? I brought this up earlier. What's negative 16 for? Influence of gravity, yeah. You don't have, what you need to know though is if it's negative 16, that's going to be in, if negative 16 c², that's in feet. Okay, the idea is in feet per second. So this model only works on Earth because of gravity. So at Niagara Falls in New York is 167 feet high. How long does it take for the water to fall from the top to the bottom of Niagara Falls? Well, what are you doing? Well, you're looking to see how long it takes. You're going to say, well, what would the height be though? Well, where's the height when it hits the gets down? No, okay, the initial height where it's starting from is the 167. What's the height of it when it hits the ground? Okay, so we're using this model. You don't have to rewrite that, it's right up there. The height would be 0 now when it hits the ground. So we're plugging in 0 for the h and 167 feet for the initial height. So we can go ahead and do this algebraically because I'm going to talk to you about the 3 different ways today that we've learned to graph. So this is obviously, factoring is not an option. We're not going to factor it, but we're going to do it by the square root method. So if we subtract 167 and divide by negative 16, we will get 167 over 16. We'll grab our trusty calculators. I was messing around with lines and geometry today. Taught them how to graph them. And by the way, make sure if anything inappropriate is on a calculator ever when you turn it on that you show me. And not find out later that I thought it was you. Okay, use them wisely. We're going to type in the square root of 167 divided by 16. I'm just going to go ahead and use the fraction. And we're going to find out that it takes it 3.23 seconds to hit the ground. We're going to go to the hundredths place. Okay, next idea. The tennis ball is dropped. Okay, if something's dropped, then you just let it go. The initial height, 213 feet. How long does it take for the ball to hit the ground? So the height's going to be 0 when it hits the ground. So again, it's just 0 equals negative 16 t squared plus 213. So we'll have subtract 213, divide by negative 16, and we'll take the square root. Now, I'm ignoring the negative answer because, why? You don't have negative time. Yep, good job. So second square root, 213 over 16. Whoops. Got 3.65 seconds. Okay, anybody need the page? Okay, now we got a stunt man working on a set of a movie, and he's going to fall out of a window 100 feet above the ground. When I read a word problem, I know a lot of kids are very worried. They don't like word problems, or they think they're harder. They really can be very, very doable. So you just need to say, oh, wait, what's this? 100 feet above the ground. What do you think? Based on what we're talking about. Is it a T? It's not a T, right? It's a height. And it sounds like that's where it's coming from. He's going to jump out of the window or fall out of it or whatever. So that's going to be my initial height for the stuntman. For his safety, an air cushion 26 feet wide by 30 feet long by 9 feet high. Are we interested in any of those numbers? Sometimes you get extra information. Helen? The 9 feet high. Yep, we're interested in that. So we want to pay attention to that. It's positioned on the ground below the window. For how many seconds will the stuntman fall before he hits the cushion? Oh, okay. So he's up there 100 feet. He jumps, whatever. He's going to hit a cushion. That's 9 feet. So you don't have to draw that. I just was having fun. All right, so now what are we gonna do? Well, we could write an equation for his height over time, which would be negative 16t squared plus his 100 feet. But we want to know when he's going to hit a height of 9, because he's going to land on that cushion. Okay, so how long is that going to take? Okay, so we have an option. One, we could put 9 in here. Okay, and then we can solve it by subtracting 100 and doing it like we did the last problems. I mean, negative 91. So we'll be doing 91 divided by 16, take the square root. About 2.38 seconds. Till he would hit the cushion. Okay, so that's a fine way to do it. I'm going to be trying to show you some other methods coming up soon. All right, a movie camera operating at a speed of 254 frames a second records the fall. How many frames will it show the stuntman falling? Well, what do you think we should do? He's going to fall for this long. Yep, we need to do 254 times the number of seconds, right? Okay, so 254 times the 2.38 would be about 605. No, it's over 6.5. It's 605 point something, isn't it? Oh, okay, about 605 frames then. I think if you didn't round this one, you could have actually gotten to 606. But I'm not going to get nitpicky, because we had already rounded the previous answer. Now we're going to have an object launched or thrown. So it adds in an extra item, v sub 0, which stands for the initial velocity. It already says that in the right here. So this new equation has another variable. V sub 0 is your initial velocity in feet per second. H sub 0 is your height in initial height. H is height in the different positions of time. And T is your time in motion. Now, explain why this does not apply to only launched or thrown objects, but to dropped objects as well. What if you drop something? Okay, what is the initial velocity if you drop it? 0, because the initial velocity when you drop it, if dropped, is v sub 0 is equal to 0. Okay, so the v sub 0 times t drops out. Okay, if it drops out, that gives you the original E's basic height equation, giving you h equals negative 16t squared plus initial height. You're back to that basic equation. If it's the initial, if you're dropping, you just put in 0 for v. Okay, so this is the one you want to know. Okay. Okay, we ready for 10b? Okay, I'll wait a second. You don't have to have my wording. You can have your own. I just wrote something. Alrighty, so a baton twirler. Woohoo! She tosses a baton into the air. She tossed it. That means she puts some speed on it. The baton leaves the twirler's hand 6 feet above the ground. What's that? That's your initial height, h sub 0, not an h. And it has an initial velocity of 45 feet per second. So right now we got v sub 0 is 45. We've got h sub 0 is 6. How you pick a word problem apart. The twirler catches the baton, not baton, when it falls back to a height of 5 feet. What's that? An h. Okay. How long was it in the air? Threw it up there. What's the good? Whip it out right there. Yeah, she didn't have to throw it above her head. No, twirl them like that. You know, flip them up in there. I don't know. Okay, she's very small. Anyway, she's going to catch it at 5 feet. Could be right there. I'm only 5'4". That would be right by my head, my shoulder, or whatever. Okay, you okay with that now, Addison? All right. We have a couple options. All right, we know our equation is this format. You don't have to write this if you don't want. I'm just teaching, so. I could put in all these values. And I could set it to 0 because I don't know what else to do because I sure can't factor this, or I can't do this by the square root method. Why not? Will I be able to get the t alone in t squared form? No, I can't because I got another t here, right? So when you see that, the trinomial, sorry, I hope you didn't mean that you couldn't see that one there. We could subtract 5. And then I don't know how to factor that, so it's not a factorable problem. What have our methods been? We've had this, you don't have to write that, but we've, oh gosh, that looks great. Okay, square root method. We've done factoring method to solve it. I can't do either of those. What's another one? Okay, graphing method, which is on our calc, or graph it, opposite of b over 2a. Problem is, if I do the graphing method, do I want this? No, that's not what I want, right? I want that, zeros, okay? So how do we find zeros? We used our grapher. Okay, is that right? I always question myself when I do that. Okay, so our option is the graphing calculator to get this answer. All right, now there are 2 ways to do it in the graphing calculator. One is to find the right 0. Okay, you got to know which 0 would be making sense. This one might be in the negative zone, and we don't have any negative time. Here we go. Negative 16 x squared. I forgot now what the initial height was. What was that? 40. I'll go. The initial velocity is 45. 45. And that was plus 1. No, we had to subtract 1 from 6. Okay, I'm going to zoom 6. Okay, you see what I'm talking about now, about which 0 I want? This one makes no sense. X is time, so this one makes sense. It looks like it's between 1 and 2 seconds. I'm going to have it calculate for me. The 0, choice 2. I'm going to hit 0 for a left bound. I'm going to hit 3 for a right bound. Yes. I didn't do that? Well, then no wonder my graph, I didn't think that was right. Look at, you caught it, Caitlin. All righty. You saw that I didn't put an X here, and I didn't even see I did that. I'm going to insert That would help. That totally changes my graph, doesn't it? Yours doesn't even look like mine then. Okay, this is better. There we go, between 2 and 4 seconds. Second, trace, choice 2, 0, enter. I'm just going to put in 5, enter. I'm doing a left bound and a right bound, and then I hit enter again. 2.83 seconds. Sounds like a familiar answer. Okay, I'm going to show you something else. Maybe this might make things look better to you. You do not have to type. I'm going to do it fast and show you what I'm talking about. What if I left out the fact that she cut, what did she do? She threw that baton up out of her hand at 45 feet per second, and it came out of her hand when the height was 6 feet, right? This would be showing the path of her baton over time. Now, we wanted to know when she caught it. Guys, you're going to have to know how to do this for a lot of future things. If you pay attention, it would be awesome. Some people weren't. Okay, what time is she catching it? How high up is it when she's catching it? 5 feet. Okay, so I'm putting that on Y2. What do you think? What kind of line will it be? Horizontal line, not a square line. No, I didn't hear. Okay, here's the deal. This might make it more intuitive to you. Think about it. It left her hand. Well, here's another time it's at 5 feet. What time she let it go out of her hand at 6 feet, right? But it actually has another spot right here at 5 feet, and then this is the next time it gets to 5 feet. And this is what's happening between. So watch this. Hit second, trace, intersection, choice 5. And then you got to make sure you're near the one you want, because there's 2 intersections. If I arrow to the right, till I see my flasher pop back on here somewhere. Keep going, keep going, keep going. It's coming down. Oh, it's coming down. There it is, back over. All right, so I'm going to say right there and hit enter. And then I'll jump on the other line, hit enter, and enter again. And then now it's saying that it takes 2.83 seconds for it to get back to 5 feet. Same answer. Okay, but it didn't hit the ground. So maybe if you like that idea, this would be the time at which the baton would have hit the ground if she didn't catch it. What if she missed, right? Unless she hit it and then it went flying. Try another problem. Okay, you and your friend are playing tennis. I like these. Your friend lobs the ball into the air, hitting it at 3 feet when it's above the court. Initial velocity of 40 feet per second. V sub 0. Initial height, H sub 0. You back up and you prepare to slam it. Is it dead? Thanks. Go ahead and plug that in. You want to smash it to win the point because she dared to lob it to you. Write an equation giving you the height of the lob tennis ball. The height of the lob tennis ball over time is going to be negative 16t squared plus 40t initial height, initial velocity plus 3 feet the initial height. At what times does the ball reach the maximum height above the court? Oh, that relates to our stuff we've been doing. We want to know when the ball hits the max. How long does it take the ball to reach its maximum height above the court? All right, remember the max? The opposite of B over 2A. All right, the opposite of B would be negative 40. That one not charged either? Okay, I have a feeling that what I got when I opened all these new ones up, we got new calculators on Friday, that they weren't fully charged apparently because a lot of seem to be going dead. We do have a big charger in back that charges 10 calculators at a time. So you can plug in yours if you ever need to, or if you have a chargeable one. All right, opposite of B would be negative 40 divided by 2 times A, which would be 2 times negative 16. That's going to be negative 40 over negative 32. which is positive 40 over 32. We're going to figure out. Grab my calculator. Just get out of there. So 40 divided by 32. 1 1/4 second. I don't want you to forget your methods for finding the vertex. Said time, which is going to be my x. What time? 1.25 seconds. And then what is the maximum height? Well, the height would have been, plug in 1.25 that we just found. Okay, so we'll do negative 16 times, am I going too fast? A little bit? Okay. You guys realize I'm just plugging in the answer we just got. What? It sure does. Somehow I missed my negative sign. Now you got time to catch up because I'm sure slow right now. I'm going to insert a negative sign. Okay. Oh, darn. I don't think I like that. What then I got to add on, what was it, 40 times 1.25, and then plus 3. 28 feet. Okay, that ball went 28 feet high, almost 3 stories. Whew. All right, if you plan to smash the ball when it falls to a height of 8 feet above the court, how long do you have to prepare for the shot? Okay, let's put on the grapher. You could put in 8, okay, in here. Let's do it like this. Let's put in our equation in y1 about the path of the ball over time. And in y2, let's put in 8 and see the intersection. So what that's going to give us is something like this, and we're going to find out that. And we'll find out the x part, which is your time. Okay, negative 16x squared, then we have plus 40x. Plus, what was that? 3. Okay. And then in y2, I'll put in 8. We're going to hit it when it's 8 feet above the ground. Smash it back at her. Okay, so that's going to be this value right here, the second intercept. So if you haven't tried this yet, let's try it now. Second trace. We want to calculate the intersection, choice 5. You're going to have to arrow to the right so that you don't find the wrong one. It's coming down. Oh, too far. I want to be above it, so I'm going to hit enter when I realize I made myself go above it. Enter again, enter again. All right, 2.37 seconds. So I got to prepare for the shot. That's probably too long to prepare because somebody probably panicked by then. And you ever seen that when they have to wait too long for the lobs and then all of a sudden, you know. Okay, never mind. I digress. All right, E. What's that? This is fun. Suppose you hit the smash when the ball's 8 feet above the court. All right, you got it. You hit it. It takes 0.1 second for your ball you smashed to hit the court on your friend's side. 1/10 of a second. You smashed it hard. What was the ball's initial vertical velocity coming off your racket? So we want to know the velocity of your smash. Yes, that is how you... Oh, Now, that is the correct way to spell racket, but when you say racket ball.
Oh, okay.
All right. All right. Next, negative 16p squared plus. We want to know v sub 0. And where's the ball when you smoosh it? When you smash it? 8 feet. Okay, we're going to figure out, oh, what's it going to be when you hit the ball and it hits the other side of the court? Okay. So now that we have it set to 0, we're going to figure out this initial velocity. Oh, wait, how long did it take? Do we have more to fill in? P is, no. P is 0.1. All right, so negative 16 times 0.1 squared times v sub 0 t plus 8 equals 0. All right, so we're going to need to calculate negative 16 times 0.1 squared plus 8. I hope you're calculating. This will not help to be calculating it when you're in the graphing mode. I was in the wrong place. What I have to add on to that, was it 8? Okay. And I got 7.84. And I forgot to put in 0.1 where the t is in the second piece. This should have been 0.1 right here. Okay, so really, I just need to subtract 7.84. And that's 0.1, which is a tenth, multiplied by 10. Should be negative 78.4 is your initial velocity. Well, how can I interpret that? Because that's not a good enough answer. Your initial velocity was 78.4. Why is it negative, saying it's negative? Relate to the problem, guys. Why did it turn out to be a negative 78.4? Yeah? Yep, ball's going down. You smashed it. It makes sense to be negative. But do we really care about the negative answer? Well, actually, no, because you're talking about what's your initial velocity. Right? So basically, you're just saying it's 78.4 feet per second. That's the speed that you put on it when you hit it. Pretty fast. Bet they go faster than that. Some of those people smash the serves at 100 miles an hour better. All right, let's try a basketball player problem. Just try to get all the sports in there. We need not all the sports, that's for sure yet. What? There's a lot more sports. I realize that. We didn't do motocross either. Okay, moving on, or badminton. All right, basketball player passes the ball to a teammate, which catches it 11 feet above the court. Okay, so this guy's up in the air. He can fly. All right, anyway, and he's catching the ball. All right, now this ball's coming up. Somebody passed it, woo, and he catches it 11 feet above the court. Just above, oh, he's not quite above the rim. Let's put his hand up here. Okay. And he slam dunks it to the hoop. Okay, you do better than that. Come on up here. All right. The first player releases the ball 5 feet above the court. Okay, so some guy's got it in his hand down here, and he's the one that threw it. We got initial, all right, I won't draw any pictures if you're going to keep it up. We got to get on with this now. Okay, initial velocity is 21 feet. I didn't draw any pictures second hour. You're lucky because I couldn't find this thing. The first player released the ball 5 feet above the court. That's going to be my initial height. Okay, you have to be able to interpret these. I've done this before. All right, he catches it 11 feet above the court. That's going to be in H, height. Okay, how long's the ball in the air before being caught, assuming that it's caught as it rises, not as it's coming down. So here's the deal. On your graph here, you would see maybe a parabola. Both of these could be 11 feet. Making sense? He's going to catch it on the rise, so we would want the first place that it reaches 11 feet. Is that making, I hope, making some sense? Because if he didn't catch it then, it could go over and come back down. So let's go into the graph first. The first thing we'll put in line 1 is, let's see, what do we got? Negative 16t squared plus 21t plus 5. In line 2, we'll put in h is 11, and then we'll figure out what one we want to know. All right, clearing this stuff out. I forgot my initial velocity. Was it 21? And it was at 5 feet when he threw that ball, and the other guy got it to slam dunk it. Okay, I can't see well, literally, but that's beside the point. Let's go and mess with our window. I really don't care about negative time. I'm going to increase my Y. Went to window. Huh? I'm just going to change the maximum to 20. Oh, guess I could. Yours doesn't have to look just like mine as long as you can see. But the point would be, I don't want to know this value. I want to know there. The first time, because it said as it rises. So I want to know how long it takes for it to get to 11 feet. So I can do second, trace, calculate choice 5, intersection, hit enter. Ooh, no, I don't want to be there. Well, I can try it and see where it goes. Now, intuitive, like you can see right here, where when I just did enter, 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 I got the wrong place. With me? All right, that's not the one I want. So I'm going to go back and hit second, trace again, choice 5, and I'm going to have the cursor over here. So I'm going to hit, make sure I'm to the left on the curve, hit enter, then enter again, and then enter again, and now it went to the one I want. So it took 0.42 seconds. Anybody need this, or want me to talk about how I got that again? Hope you're practicing on the calc. All right, the third model is also for an object being thrown or launched. This is 11A. This model is for objects with rate of meters per second. The number changes to gravity. It's meters. Meters are bigger. I said 11 was going to be worked on today. I'm only going to do a tiny bit on here. So, gone through a water balloon. And when you got to read carefully, make sure you notice if it's in feet or meters. Then you know which one to use. Same ideas, exactly. Write an equation describing the relationship between the balloon's height above the ground over time. Height of the balloon after 2 seconds, blah, blah, blah. All right. So these just have the same variables. It's just it's in meters now. The assignment is worksheet 11 and 12. Okay. Write an equation describing the relationship between the balloon's height above the ground over time. T plus 20. That just says what's the height of the balloon after 2 seconds. Let T equal. That's just a calculator. Put it in your calculator and type away. Okay, and then how long did it take for it to reach the ground? We'll get off the grapher. Did you guys plug into, you should have gotten 20.4 meters. I don't know. Did you type it in? Anyone verify? Thank you. 20.4. All right, now I'm going to go and put it in and find out how long it takes to reach the ground, and that's by the graphing calculator. I just re-standardized my window. No, I didn't. Thought I did. All right, and we'll want to know it's a little over 3 seconds. I'm going to go second, trace 2. We'll do a left bound 0, enter 6, enter. I just made up some numbers. And it's at 3.83, 3.23, sorry. I can't, I'm dyslexic today. 3.28 seconds. Okay, this is just throwing a stone, same ideas. What were you doing? All right, I'm going to stop here. Do you have homework practice?